Hi and welcome. This time around I have a new tool from Vevor that I'm going to take a look at that really applies well to what we do as machinists, especially if you do work on lathes. It also will cross over into welding markets, and just in general, this being a fairly inexpensive tool has a lot of really good uses. This is Vevor's stainless steel pipe polisher, and it's basically a very adaptive belt sander that uses 1.5 by 30-inch belts. So let's open this guy and take a look. This one is shipped and packaged really well. I've already opened this up because I thought it was something else. Double-sided, double thickness cardboard here with an internal box inside. As you can tell, I ripped open the side already, and this would be the tool right here. This tool is currently listed for only $139 on Amazon, which is just an amazing price. Looks like they got instructions and spare brushes for the motor. Came with a belt, very coarse belt, but these 1.5 by 30s are a standard item. You can find them at a bunch of vendors selling abrasives, so that's a good thing. You don't have to get it through them, or they're not custom. This is a very coarse belt. This is a 60 grit. Wow, that's an interesting packaging right there. So this is a very adaptive design belt sander, and what this thing's designed to do is flex around round objects and at least sand half the diameter at a time, or circumference, half the circumference at a time. That's probably a more accurate description. This will be great on the lathe when you need to do a final polish up, not with 60 grit, but or you need to bring something into dimension. Use something like 400 grit or 600 grit, so you're taking off just a little bit of material and you can just bring something in when the cutting tool leaves a nasty finish. Anyways, that's why I'm excited about this guy. I asked specific for this. This wasn't something they were promoting, but this is something I've for a long time thought would be very useful, especially when I saw A-Bomb use one in the old days, back when he was working for the hydraulics company. Anyways, let's get this guy out of here and take a closer look. So you can see here that this is essentially a large heavy-duty angle grinder attached to a spindle that will drive a belt, as well as 2 idler wheels. And as a matter of fact, you can buy attachments that fit on standard angle grinders to do this. So that's another option to look at. This is an 800-watt motor. I like it's got an on-off switch instead of complicated safety paddle and crap like that. Speed control on the back. Loading the belt is very easy. It does have a direction, so let's see. What if I guess that it goes so that the belt goes down? I don't know. Actually, I should plug this guy in and find out which direction this guy rotates, because I want to get the belt in the right direction, even though the seam in the belt looks like it would work fine in both directions, but they did go to the effort of putting arrows on here. Still got a safety catch on it. Okay, so it's going this way. So the belt goes on this way, and it's just one spring-loaded side. So really easy to change belts on the fly. There's 1 to 6. The beauty of this design is that you can push into something round. That's what they're expecting. That's why when it's free running, there's a little bit of slop in the belt, because they're never expecting it to run like this. When you push in on something that you're trying to sand, then it wraps around, which is really handy. And if you get in far enough, you can do half the circumference at one time. What this will be especially useful for is turning something on the lathe and wanting to just remove some tooling marks or do final polishing. There are sanding pad belts for this that you can get with Scotch-Brite material like this. So they have belts made out of this material. There's of course standard sanding belts, so you can do final polish ups and remove tooling marks really nicely with this guy. I've wanted one of these for a while. A-Bomb used one on his channel back in the old days when he used to do large hydraulic stuff, and it always looked really useful. So I've been looking for one for quite a while, and Vevor came out with one. I thought this is a great situation. Oh, there was an arrow to show which direction the belt goes, and I think they intend for the handle to go this way and use it like this. So 800 watt motor, 2.49 amps. They're saying it's 700 to 3,000 RPM. There's a rubber, this is steel. There's rubber inserts inside of here. These are plastic idlers, but have ball bearings inside them with rubberized insert on that one. And this one is just a hard plastic, and that's about it. If you were using this every day to business, you'd wear it out, but at 139 bucks, if you got a few years out of it, that would probably be adequate. So this guy is based on a regular angle grinder, but let's take a closer look. Let's take this assembly off just to see how it was mounted, just for interest's sake. So it looks like the belt guide, these plates on the outside here, just unscrew, which should give you access to whatever's inside. My first guess was they used the normal nut that holds the wheels on, the flap wheels and the grinding wheels on, but now I'm not so sure. And no, it's a casting, aluminum casting. And fortunately, they left the lock on here. And I already loosened this, just so you know, it wasn't that loose. But it self-tightens to the direction that it rotates, it'll self-tighten. And then this whole assembly comes off with 4 bolts here. And the interesting thing that I noticed is that they plan to have this work potentially with multiple grinders, because you see there's the other 4 pre-drilled, like spot drilled holes, except they're not spot drilled, they're in the casting. Looks like for this mounting on a different angle grinder, which I guess if your supplier for grinders is not guaranteed, as things seem to come and go a lot in China, the brands, that'll give you a little more versatility in your product, so you won't rely on one manufacturer's grinder bolt layout just in case they change, which is interesting. I wonder if there's a standardization among them between, you know, these 2 bolt layouts, and this covers a bunch of different grinders. That way you won't have to worry about it as much anyways. Everything seems to be very fluid over there. All right, so this whole assembly comes off, and you could obviously mount this on a different 7 or 8 inch angle grinder body if it fit. And then you're left with the standard angle grinder here. And I did notice that the handle holes go right into the mechanical casting, which is a really bad idea if you're not going to fill them in with something, because all the grit and dust that's in the air, some of it will inevitably find its way in there and get on the gears. That sounds like a really bad idea. So I've got some set screws here. Let's see if we have any that match that. Oh, I didn't mean to do that. That was not that size. Yeah, they always look different. And since that hole goes all the way through, now I got to take this apart. I wasn't planning on taking the head off this, but now that we've dropped an Allen screw in there, what did I say about getting dust and grit in there? I hope this section pops right off here, but I could see where they could design this so that the gear is a press-on, and then you can't get this section off without popping it off the motor shaft. I'm curious how they did this. This is threaded into plastic, I'm guessing, based on these screw threads. Oh, thank goodness. Oh, okay. Hey, kudos then. So, although this does open up to the inside of the casting, they kind of had the 2 pieces meet. So there's the motor shaft, and it's enclosed. Yeah, it's enclosed, so it looks like dust wouldn't get in directly. So it's not as bad as I thought. That's kind of creative. And it looks like they greased it reasonably, and then just as you ran it, it spun all the grease to the outside, which means it'll probably never get on there again. Since they did provide you with spare motor brushes, which I find fascinating, you would think they'd make access from the outside to the motor brushes, but it doesn't appear they did, and it looks like it's still a clamshell design, which means getting to those brushes means taking this whole back section apart, which historically has not left you with a very easy to reassemble section. Different size screws. right, so the two front ones are longer than the rear. Ah, okay, not bad. Not bad at all. Yeah, that came apart pretty easily, and there's the motor brushes. Looks like they're pretty easy to put new ones in. You just pull the spring back and pop a new brush in. The switch is actuated by this long plastic bit that goes to the front, which they sealed from dust, which is a nice touch. And then the lock is part of the plastic piece here. So when you push forward, if you push in, it locks, and you pop up, it unlocks. Pretty straightforward. Speed control is a solid state circuitry here. It's potted, so you can't see much relating to it. And it looks like they even have a RPM sensor, I'm guessing. I don't know why else they'd need that. Well, not bad. Even got some decent strain relief on the cord in two different places. This is the bend protector and then some decent strain relief there. Yeah, not bad at all. It's also interesting to note they designed this clamshell to catch on the front here and hold against the plastic of the motor housing as well. And once you've popped it apart, it goes back together really easily. So that's kind of nice. It was a little stiff coming off, but really easy going back together. Ah, nice. All right, so I decided instead of the set screws, since these threads are really loose, I'd have to use Loctite, and that doesn't seem as nice. So I'm going to use this aluminum ductwork tape, or air conditioning tape. And that we also know that there's no direct access to the mechanics, that they actually bring the metal parts together. I don't know if there's a gap because you can't tell until you close it. I suppose you could, mark it with some bluing and then close it, but I'm not that interested. So I'm just going to put some tape over these holes. I'll never use them anyways, and we'll go from there. Don't need to waste some stainless set screws on that, and we'll put the rest back together. All right, so I put some aluminum tape over both these holes. Just going to stick this sanding assembly on here, back on here, I should say. Tighten those four on there. And just thread this guy back on here again. Fortunately, the direction this thing rotates itself tightens, so that's nice. They could have used reverse threads if that hadn't been the case, but it is, so everything's working out fine. And put the belt guide back on, which is just stamped sheet metal. Fairly thick, though. All right, so we're ready to rock and roll. Let's head over to the lathe and try this guy out. All right, so here's a variety of belts. I just got a shipment from Amazon. This is the one belt that came with it. It's sort of a copy of the Norton something fire belts, the blue ones, kind of cool color. This is a zircon-based belt, unknown manufacturer. Aluminum oxide, unknown manufacturer in various grit range, and a Scotch-Brite ripoff here. And maybe we'll try the Scotch-Brite ripoff over on the lathe, see how it does. This is a fine, not an ultra fine. So as you've probably seen, getting a good finish on cold rolled steel, which is what this is, can be pretty challenging to get a decent finish if you're taking a light cut. If you take a deep cut with a high feed rate, you can get a decent finish. You notice once it's a deeper cut, you start to get a better finish. So if I pull this cut out, notice it gets worse. Alrighty. So that leaves us some pretty unattractive finish material there. It's mostly smooth by the hand, but I think it's soft and it gets tear outs in it, because you can sort of feel as you're going across it. There's some little bumps here where I think the material, like a bigger chunk, comes out. Anyways, let's take the sander over here and see what kind of finish we can get. One thing I would recommend is be careful about how you put it here, but I would recommend putting some sort of protective cloth over your ways to keep the abrasive dust away if you're ever going to do any quantity of sanding. And now, the belt on the cutter is going to be going this direction, and currently the lathe is turning this direction, which means it's reducing the effective sanding belt speed. If I run the lathe in reverse, the part will be turning this way around here. So it'll be coming up this direction while the sanding belt's going down, and that'll probably remove more material or get things done quicker. And it turns out, by the way, these Scotch-Brite belts are genuine 3M. I couldn't read the text, but I started looking more closely, and either they copied them or they are genuine 3M belts. So that's pretty cool. So I'm going to run the lathe in reverse. And that was pretty quick, and that's low speed. Let's turn this thing up. Does a really good job of not loading up. That's a pretty smooth finish. So it doesn't get into the corners obviously well because it starts to ride up, but it did clean up this spot pretty nicely. Now there's some deep cuts into this part here where it actually slipped in the chuck jaws, and you can sort of see the parallel lines as it rotated in the chuck jaws. So let's take some sanding paper, replace the 3M belt with a sanding belt, and see if we can get an improvement there. Put a 150 belt on here. That's the wrong direction. That was some 150 grit. Made quick work of that. It's a pretty rough finish, but took most of those grooves all the way off. All right, let's step up one, see how nice a finish we can get. Jumping straight to the 400, which is a pretty big jump. That is much smoother. It would help if you'd walk up in grit, so I just jumped straight. Let's do a finish with a Scotch-Brite. Belt swapping is really quick, so it's not a pain at all. And that was real time. That is a very nice finish. I didn't get all the scratches out of it. I need to go a little deeper with the 150, but they were in there pretty good. It was the 6-jaw chuck that did it, and when it spun, it threw up huge burrs in it, and you could definitely feel it. But you can tell that that was only, what, 30 seconds, 60 seconds? Pretty nice finish. So overall, I think this is a great tool, especially for the price. You know, it's relatively inexpensive, well, very inexpensive, and you can do a lot with it. If you want to tune in and just get some material to final thickness, like if you've got a long part in here supported by the tailstock, the middle will deflect a little more than the edges. So if you need to take a couple tenths off either side, you can use the 3M pad or very fine sanding paper to take it off and dial yourself in. You know, in the old days, you know, normally you take a piece of sandpaper and just pull it around like this. This is a piece of leather, but to demonstrate. And this just speeds that operation up and gives you a little more control. So I'm very much in favor. I think Vevor's got a winner here, especially for the price. So I think this is a nice addition to any shop if you have a lathe and you do lathe work to any precision. Thanks for watching. Hope you find it useful. Hope to see you next time.